Okay, so we're doing the integral of a squared minus x squared being square rooted. We've actually done this before. We used a substitution, x equals a sine theta for that one. But I'm going to do this one as an integration by parts, just out of interest for practice and so on. But by parts, as you recall, we have a formula, and the formula is that the integral of u dv dx is equal to uv minus the integral of v du dx. That's our formula. So we need a u and we need a dv dx being times together up here. But actually there's only one function up here. So what we do about that is we put a 1 into the mix. So this function here is actually the integral of root of a squared minus x squared times 1 dx. Now I can have a u and a dv dx, and my u, of course, will be the algebraic function a squared, root a squared minus x squared. So that's a squared minus x squared to the half. So I need to find du dx. And that will be the power times the derivative of the function times the function raised to a power less 1. So that'll be minus x on the square root of a squared minus x squared for our du dx. And on the other hand, we have our dv dx, because in our formula we've got a u and a dv dx. The u was that, so that's the u, so that's the dv dx, is 1, so it's easy to find v, that's just x. So now our integral that we're trying to find, if I can just refer back up to here, it will be the integral of u times dv dx is equal to u times v minus the integral of v times du dx. So just to put back what we've done here, so you can have a look at that. We worked through from here, found u and du dx and dv dx and x, and I've popped them back into this green formula. Given that that's u and that's dv dx, I've popped them in the green formula and written that up the top there. All right, so let's now proceed, because that's probably the hard part of it done out of the way. Let's now sort out what this will actually be. I think that we need to concentrate on dealing with this bit here. So as its own separate thing, let's bring this minus integral of minus x squared on root a squared minus x squared over here and deal with that. So that would be equal to minus the integral of, now I'm going to do something. I'm going to put my minus x squared here and root a squared minus x squared there. And I'm actually going to add in a minus a squared and a plus a squared. Now you can see why I'm doing it, because it's going to make life a little bit easier. if I can separate it out and do that division there, because these are basically the same function, just raised to a different power. So just bear with this. This would be minus the integral of minus a squared on root a squared minus x squared dx. I'll throw that in there. And then plus, better be careful because there's a minus out the front of all this, plus a squared minus x squared on root a squared minus x squared being integrated. So just managed to separate them out. That's to the power of 1 as such, this guy over here, that's to the power of 1, and that, if you were to put it to a power, it'd be the power of half. So it's like having y over root y. What do you end up with? You end up with root y as your answer. So we've actually turned this bit here into, we're just trying to do the integral of root a squared minus x squared dx. Now you think, hang on a minute, what was the original question that you were trying to answer? Wasn't that the exact same thing? I'll just have a look through these bits of paper I've got here. There's my original question, root a squared minus x squared dx. And I've created another one of those. Well, it's deliberate, as you can see from the example we did before, because I'll be able to join that together, maybe have 2 of the original integrals and work it through from there. So that's all good. We're happy with that one being there. Since there's a minus there, a minus of a plus, I'm just going to put a minus there, and now I'm going to deal with this guy as its own separate thing. So this guy, this front guy here, is a squared, because minus of a minus. So it's the integral of a squared on a squared minus x squared is being square rooted. All right, so does that look familiar to you in any way? That sort of a thing. Yes, it does. This looks like inverse sine. Inverse sine is 1 on root a squared minus x squared. So if I pull that a squared out the front, if I was to go to my formula sheet or wherever and look up the inverse sine formula, it would be looking good. So this here, this 1 on a squared minus x squared is just the inverse sine of x on a. So this is, we've got our a squared, this will be inverse sine of x on a, because that's what that is for that formula, you can look that up. And this is minus the original integral that we had. So that's looking good. But all I've just dealt with there, with all this part of the page, was just this guy over here. Just this part I dealt with. I brought it down, and all of that has just sorted out that guy. So now I'm going to write out what I've actually got here in one long sentence. I've got, sorry, I'll just move that one along. I've got the integral of root a squared minus x squared dx equaling x root a squared minus x squared, and then minus. Now I took into account that minus that was there. I brought it down to here and worked it through. So this whole thing that's in the red is just plus a squared inverse sine x on a minus that. So I'll just write that down. Plus a squared inverse sine x on a, and minus integral of root a squared minus x squared dx, which This guy here is just the original one, which we're happy with because I can just add this onto both sides. So if I add that onto both sides, I'll get two of these. I'll get this plus another one of them. So I'll actually get two of these integral of root a squared minus x squareds equaling x root a squared minus x squared plus a squared inverse sine of x on a plus c. I'll put there in a minute. So I've got two of those equaling that, which means if I divide by 2, the integral that I'm trying to find, that is just like x root a squared minus x squared divided by 2 plus a squared inverse sine of x on a divided by 2 plus c. Now, I probably should have thrown a plus c in up here as I was working, and when I divide by 2, if that was like my plus c and I called it c1, then this value of c would be c2. But I'm actually just interested in working through the integration bit, so that's why I've left that out, not to complicate things. Thank you.